Alright. For this lesson we have two objectives again. We're going to be able to define the domain and range. And two, we're going to be able to identify the domain and range given a graph of a function. Okay. So again, pause this video if you need to write that down. So again, let's start with that same factory that we've been working with our input of cotton and our output of a pink sheet of fabric with polka dots on it. There are other inputs that we could take into this factory to produce fabric as well. We could bring in silk or we could bring in wool, and I'm sure you could think of other items as well. Well, let's just use these three things for this example. Okay. Here's a vocabulary word for you to write down in your notebook. It's something we'll be using throughout the year. Whenever you have a function, you have possible inputs, and all the possible inputs are called a domain. Now notice in math, we have this three-dot triangle which represents therefore. So in this case, the domain of our factory is cotton, silk, and wool. Now there is a special way of writing this, and we will be doing this throughout the year, so you will get used to it, but here's a little introduction as to how we write the domain. We would say D colon, and then we have these funny looking brackets. These brackets represent a set of numbers or a set of items. In this case we have a set of items. We have the set of items which is cotton, silk, and wool. So we would write this as domain is cotton, silk, and wool. Okay. Let's continue on. Let's use that same factory again. Okay, we have the input of cotton. We have the output of a sheet of fabric, and we have other outputs. Well, instead of making a pink sheet of fabric, we could make green, blue, orange, gray, purple, or any other color you can think of. So pretty much any combination of dye would make up a color, so we could have any color output for our fabric. Okay. Another vocabulary word. All possible outputs of a function is called the range. Therefore, the range of our factory is all colors. And the way we would write that is range colon, and then we do have a set of numbers or set of items. We have a set of items this time. They're colors. So range is the set of all colors. And that's the way you'd write that. Now, you could write down every possible color, but that would take you a very long time, so we could just make the general description of all colors. All right. Let's think about a gumball machine. Can you decide what the output would be, or what its range would be? Okay. Would the range of this be a quarter? Would it be a gumball? Would it be cavities? Or would it be turning the handle? And again, you always have the option E, which is none of the above. So pause this video right now. Think about what the range of a gumball machine would be and answer that on your multiple choice section of the Google form. All right. Let's take a graph. We can identify the domain of the graph, which is all possible inputs, which is the x values. So look at the graph and think about what are all the possible x values that are possible in this graph. All right. Well, when I think about this, I look at the smallest number and I look at the largest number. So it goes from -6 to positive infinity. There is an arrow, meaning it goes on forever. But -6 definitely is the smallest number because it has a point there. It does not move any farther left. Now again, using our domain notation that we learned in the previous slide, we would write this as domain is the set of numbers going from -6 to positive infinity, and we write this using this form. We'd write down the smallest number, which is, and then we'd put the x in between, and then we'd have the largest number. And you'd always use the less than symbol, but you'd have to think about, is it equal to or is it not equal to? So looking at our graph, you can see that it is definitely equal to -6, but you can never equal infinity. So we'd write this as the domain is a set of numbers which ranges from -6 to positive infinity. We're going to look at that same graph now, and we're going to identify the range. And remember, the range is all the outputs, which in this case are the y values. So again, looking at this, or figuring out this the same way that we did the domain, we'll look at the smallest y number, which is 0, and we go to the highest y value, which is again the arrow. The arrow says it goes on forever, so that would be infinity. So we'd write this as the range is the set of numbers from 0 to infinity, and again we'd use that same notation. We'd write down the smallest number, which is less than y, which is less than infinity, and it looks like I have a mistake here. So let's erase this equal. Oops, sorry. Alright, so I erased the equal sign because it can never equal infinity. Infinity is some largest number that is not identified, so it can never equal the largest number. So that is the domain and range. Let's look at another graph. Notice this graph has 2 points. There's no arrows. So we'd write down the smallest number, which is -5, to the largest number, which is +4. There are 2 closed circles. Closed circles mean that it is equal to. So -5 is less than or equal to x, which is less than or equal to 4. Okay. Now if they were open circles mean that they are not equal to. So that would just be a circle that's not filled in, and that would identify a point that's not equal to. Well, your short answer for this video is to tell me what the range is. Okay, be careful. Common answer here would be -5 to +4, but that's not the case. Remember, you're working with the range, and the range again works with the y-axis, not the x-axis.